Hello ma'am, my first question is what is isothermal process and what are the formulas that are used in this process? Second question, solve one problem on constant temperature process and show this process on pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram.
When any process is taking place at constant temperature, then that process is known as isothermal process. Now when steam is superheated, then it behaves like a perfect gas. And we know what is the law for perfect gas, that is PV by T is equal to constant. But for isothermal process, during the process 1 to 2, this temperature will remain constant. And that's why we can say that PV is equal to constant. Now how to calculate the heat transferred for the isothermal process, where T remains same throughout the process. So process 1 to 2 is taking place where 1 is for initial condition of steam and 2 is for final condition of steam. So heat transferred Q12 is equal to T into ds, where T remains same during the whole process from 1 to 2 and ds is the change in entropy, that is S2 minus S1. Now in the same way, how to calculate the work done? So work done during the process 1 to 2, that is W12 is equal to Q12, that is heat transferred minus change in internal energy dU, where dU is equal to U2 minus U1. So these are the important formulas for the isothermal process. Now we will solve one problem and we will understand that problem with the help of pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram. I will read what is the given question. Steam at a pressure of 5.4 bar and dryness fraction 0.8 expands in a cylinder reversibly and isothermally to a pressure of 1 bar. Find final condition of steam, change in internal energy, change of entropy, heat transfer, work done per kilogram of steam. So this was the given question. Let us first understand what is the initial and final condition of steam with the help of steam table. Now initial condition, it is given that pressure P1 5.4 bar and the dryness fraction X1 0.8. So here dryness fraction is given, that means initially the steam is wet steam. So we will say that here the condition is wet steam. Now what is the final condition of steam? So here isothermal expansion process is taking place. That means temperature will remain constant. So what is the temperature for the initial 5.4 bar? So if we refer here the pressure table, so in the first column pressure is given 5.4 bar and temperature is 154.8. So I will write here, that is temperature T is equal to 154.8 degrees Celsius. Now this temperature will remain constant because isothermal expansion process is taking place. So final condition of steam, P2 is equal to 1 bar and temperature T is equal to 154.8 degrees Celsius. That will remain same. But what is the saturation temperature at a pressure of 1 bar? So again we will refer here the pressure table and we will find out what is the temperature at the 1 bar. So here for 1 bar pressure the temperature is given 99.63. So here this temperature is more than this 99.63 degrees Celsius. So we can say that this temperature is the superheated temperature. And we can say that final condition of steam is superheated steam. So I will write this is the superheated steam. So this is the answer of first question, that is this is the final condition of steam. Now we will show the process 1 to 2 on this pressure volume diagram. So what is happening here? The pressure is getting decreased during the expansion process. So we know that as the pressure is getting decreased, volume is getting increased. So we have to show this point 1 and 2 on the pressure volume diagram. So how to show this? Now we will select here in the wet region, because initial condition of steam is wet. So I will select here point 1, that is this is the wet steam. Now pressure is getting decreased and volume is getting increased. So here is the volume. So we have to show point 2 in the superheated region, because final condition of steam is superheated. So we will show here with decrease in pressure and increase in volume. So this will be our point 2. So I will show this with arrow. Now here is the pressure P1, now pressure P2, here is decrease in pressure, here is volume V1 and here is volume V2, that is increase in volume. So this diagram is getting completed. Now we will move for the next, that is the change in internal energy. So change in internal energy, that is U2 minus U1, that we have to find out. So what is the value of U1? How to calculate the internal energy at point 1? So there is the common formula, that is H1 minus 100 P1 V1. Now why the number 100 is used? Because if we observe, the pressure is given in bar, and here we have to take the unit of pressure as a kilopascal. So we have to multiply here with 100 to convert this pressure in kilopascal. So whenever the pressure is given in bar, then we have to take here 100 P1 as a number. Then now what is the enthalpy for wet steam? Because initially the steam is wet, so H1 is equal to, we have to take with dryness fraction HF1 plus X1 HFG1. So how to find out the value of HF and HFG? So pressure is given 5.4 bar. So again we have to refer here the pressure table. At 5.4 bar, value of HF and HFG is given 652.8 as well as 2098. So we have to take here the value of HF and HFG, and dryness fraction X1 0.8. Now what is the value of V1 for the wet steam? So V1 is equal to X1 VG1. So X1, that is the dryness fraction, and Vg, so at 5.4 bar Vg is given 0.348. So we have to refer from the steam table. So when we put value, we will get 2181 kilojoule per kilogram. Now we will calculate U2. So internal energy for superheated steam, U2 is equal to, so again formula H2 minus 100 P2 V2. Now for superheated steam, we have to find out what is the value of H superheated. So we have to refer here the superheated steam table. So at the end of this steam table, specific enthalpy for superheated steam is given. So we have to take that table, that is here is the specific enthalpy for superheated steam. So what is the condition? Pressure is given and temperature is given. So in superheated steam table, here the pressure is given in this vertical line, and on the horizontal line temperature is given. So 1 bar pressure is there. So we have to refer here 1 bar pressure, and temperature is 154. So here 150 degrees Celsius is given. So H superheated, that is we will refer here 2785. So we have to calculate this, that is 150 and 200 is given, but we want here the enthalpy for temperature 154. Now pressure will remain same, that is 1 bar. So how to calculate here? So we have to take the difference in between temperature. That is, I will take here 200 minus 150 divided by 154.8 minus 150, which is equal to, now we have to take enthalpy of 200. So if we observe here, enthalpy for 200 is given 2875.4. 2875.4 minus for 150 it is given 2776.3 divided by, now 154.8 enthalpy is unknown, so I will write here x minus again for 150 2776.3. Now we can easily solve this equation. Why? Because only one unknown term, that is x, and we can calculate this x, and this x is nothing but H superheated, that is 2785.8. Now in the same way we will calculate V superheated. So for V superheated, again the specific volume for the superheated steam is given. So here is the table. Now again we will refer here for 1 bar and 154. So 154 is not given. 150 and 200 degrees Celsius is given. So we will apply the same formula here and we will calculate what is the value of V superheated, that is 1.96. So when we calculate this, we will get 2589.8 kilojoule per kilogram. Now what is the change in internal energy, that is dU, which is equal to U2 minus U1 and which is equal to 408.8 kilojoule per kilogram. Now we will find out the change in entropy. So how to calculate the entropy for wet steam, because initial condition, that is the wet steam, that's why we have to calculate S1 is equal to SF1 plus X1 SFG1. So this value of SF and SFG we have to take from the pressure 5.4 bar by referring the pressure table. So if we put the value, then we will get 5.81 kilojoule per kilogram Kelvin. Now how to calculate the entropy at point 2, that is for superheated steam. So here we have to refer the table for the superheated table, that is the specific entropy of the superheated steam. So now what is the condition that we have to take? We have to take pressure 1 bar and temperature, that is T superheated 154.8 degrees Celsius. So again if we observe here 150 and 200 temperature is given, that is 150 degrees Celsius, 200 degrees Celsius temperature is given. So at 1 bar we will again take the calculation, or we will take here the pressure will remain same. Now we have to find out what is the entropy at 154. Now available temperatures are 200 and 150 and in between that there is the value of 154. So how to write? That is, I will write 200 minus 150 divided by 154.8 minus 150, which is equal to, now we have to take the respective entropies. So at 1 bar at 200 it is 7.835 minus 7.614 divided by, now this is unknown, at 154.8 it is unknown, minus 7.614. So when we solve this we will get the value of X, and that is nothing but the value of S superheated, and that is equal to 7.635 kilojoule per kilogram Kelvin. Now we will calculate what is the change in entropy, that is S2 minus S1, which is equal to 1.825 kilojoule per kilogram Kelvin. Now how to calculate the heat transfer? So heat transfer, that is nothing but temperature. So temperature will remain same throughout the process. So T multiplied by ds, that is the change in entropy. So this temperature we have to take in Kelvin. So this temperature is 154.8. So 154.8 plus 273, that is equal to 427.8, and this ds, that is change in entropy, 1.825, which is equal to 781 kilojoule per kilogram. Now how to calculate the work done? So work done during the process 1 to 2 is heat transferred minus internal energy. So in change in internal energy du, that we have already calculated. So work done is equal to 372.2 kilojoule per kilogram. Now we will show the process on this temperature entropy and enthalpy entropy diagram. So we know that the temperature will remain constant. So first initial condition is the wet steam and final condition is the superheated steam. So we have to select here point 1 in the wet region. We have to show temperature will remain constant. Now if we compare the value of entropy S1 and S2, then entropy S2 is greater than S1. So entropy is getting increased. So we have to show here the temperature will remain constant. Point 2 will be on this in the superheated region. We have to show arrow. So here is S2 and here is S1, and this temperature T will remain constant throughout the process. Now how to show enthalpy entropy diagram? Now here we have condition, that is pressure is given and dryness fraction is given. So in enthalpy entropy diagram, if we observe, here are some pressure lines. So say suppose this is the 5.4 bar pressure line. So I will write here 5.4 bar. And at the bottom here the dryness fraction lines are given. So say suppose this is the line for x is equal to 0.8. So this point of intersection is nothing but the point 1. Now we will move for the next. For final condition, pressure is 1 bar and temperature is 154.8. So again, parallel to this pressure line, here there is the pressure line for 1 bar. So we have to select this 1 bar pressure line, and temperature is 154.8. So in the molar diagram or enthalpy entropy diagram, here in such a direction the temperature are given. So suppose this is the temperature of 154.8 degrees Celsius. Then this point of intersection is nothing but point 2. Now when we join this point 1 and 2, then this is the process 1 to 2 in the enthalpy entropy diagram.